about it. I understand a couple of people have some questions about 1C, so I'm going to go through 1D and then come around and see what some common questions are, and then maybe we can go through some stuff together. Now 1D, we've got a bit to get through, but it's all stuff we've done. We're not learning anything new here, so this is just revision from year 11 and from your holiday homework if you did it. So 1D, we've got our unit circle there, and we've got some important definitions. The x coordinate is cos of theta, y coordinate sine theta. We've got sine squared plus cos squared theta is 1, and tan theta is sine theta and cos theta. So they're the three fundamental identities for the trig. Then we've got a description of what's the difference between radians and degrees, and how to convert from radians to degrees. So that's all there. And then it's just straight into some questions of trig operations, and then we've got some stuff about graphs. Okay, so we're going to go through all of these. We've got find cos theta, tan theta, and sine theta, given theta is 7 pi on 6. So this means find the x coordinate and the y coordinate, given theta is 7 pi on 6. So we're looking at our unit circle, we go, where's 7 pi on 6? We've found it. Okay, remember cos is the x coordinate. So that's going to be cos of theta, and in this case theta is 7 pi on 6. And we've got minus root 3 on 2. We've got sine of 7 pi on 6 is negative half. And then we're asked to find tan theta. And tan theta is not listed on our unit circle, but tan theta is just sine theta divided by cos theta. So that's going to be minus root 3 on 2 on top of minus 1 on top of 2. So here's a good way to think about these fractions. I'm going to say two things here. Firstly, we've got two negatives in there, all right, which means they're going to cancel. We've got a negative divided by a negative, so we can just get rid of them straight away. If there's only one negative present, then it's going to be negative. If there's two, they're going to cancel. If there's three negatives, then it's going to be negative as well. All right? But you should never end up with three negatives because that negative belongs to the whole fraction. So if there's one negative, the whole thing is going to be negative. If there's two, it'll be positive. Right, so then one thing I like to do is just when we're talking about dividing fractions, okay, we've got four things, A on B on C on D, and that's just equal to AD divided by BC. Okay, the top times the bottom divided by the product of the two middle ones. So that's going to be, we've got minus root, now we can just disregard the negatives completely, okay, we've established that they're disappearing. We've got root 3 times 2, so that's just going to be 2 root 3. You can put a times in there if you want to, but it is obsolete, we just write 2 root 3. On top of, we've got 2 times 1, which is 2. We've got 2 at the top and 2 at the bottom, so that'll cancel. And so our answer for tan theta is root 3. So sine and cos we can just extract from the unit circle. Tan we have to process a little bit. Okay, question 2. Find the value for theta between 0 and 2. Sorry, Matthew?
Didn't you say it's sine theta and cos theta? Yeah. You say
I've put it in the wrong way, have I? Thank you. So, yeah, let's fix that quickly. So it's negative half on top of root 3 on 2. And so, yeah, now we're going to have 2 at the top. This will just be around the opposite way. 2 on 2 root 3. And so our answer is 1 on root 3. Okay, good pickup. Well done. So, find the value of theta given 0 is less than theta is less than 2 pi. Okay, so that means we're talking about one revolution of the unit circle. We're only going around once. Cos theta is root 3 on 2. And it says, what's the angle that makes this statement true? So on our unit circle, okay, remember cos is the x values, and this is positive because there's no negative there, so we know it's positive. So we're talking about positive x values, and we're talking about positive root 3 on 2, which is about 0.86. So it's going to be here and here. Okay, we can establish that just through reasoning without knowing what the value of theta is. And so we know where it's going to be, and we just look at our unit circle, and we're looking at where the x value, remember cos is the x value, where the x value is root 3 on 2, we've got pi on 6, and we've got 11 pi on 6. Okay, now the question is asking in radians, so that means our answer must be in radians. Okay, if the question said between 0 and 360, then you would use, you would answer in degrees. Now I've never written a test with questions in degrees for Year 12. I've never seen a question in the exam in degrees either. Okay, so I'm going to say with 95% certainty that you're only dealing with radians. Okay, but we do teach you it, and so it is assumed knowledge. Okay, moving on. We've got part B, 2 sine theta equals half. Okay, so here the 2 sine theta is 1. Here we need to do a little bit of working out. Okay, first we need to isolate sine theta by itself. This is our variable, so this is what we're trying to find. So we're going to divide both sides by 2, we get sine theta is half. And again, let's think about it, let's be intuitive. Here's our unit circle. Sine theta is the y values. So we're talking about the y values being positive half. So here's positive half, and so our 2 locations are going to be here and here. And we can just look at our unit circle to establish what the answers are to that. So we've got sine theta is positive half. We've got pi on 6 and 5 pi on 6. Okay, everyone following along with this? Swap the text to there. Excellent. Now, sorry, Tess, I think I've got home. I'll go get one. Okay, C. Okay, so we're just building up a little bit more operations involved. We've got 3, take away 4 sine squared theta equals 0. So we want to isolate the trig ratio by itself. So we're trying to get sine theta all by itself. So our first thing, let's subtract 3 from both sides. So we'll get minus 4 sine squared theta is minus 3. We're going to divide both sides by minus 4. Okay, so that we've just got sine squared theta is, and it's going to be positive 3 on 4, because minus 3 divided by minus 4, the negatives cancel. Okay, we can do anything we want to an equation, as long as we do it to both sides. We want to get rid of the squared, so we're going to square root both sides. Now, just in terms for terminology, when we're talking about sine squared theta, that's how we write it. But this is what it means. Okay, it means sine theta squared. Okay, sine theta times sine theta. So what we're going to do is we're going to square root both sides. So I'm putting a square root here and a square root here. And so we're going to get sine theta is plus or minus the square root of 3 on 4, and we're just going to process that a little bit. Okay, that's going to be plus or minus root 3 on root 4, which is plus or minus root 3 on top of 2. Okay, now what are we trying to do here? What's the question saying? Find the values of theta that make, what we've done here is we've processed this, that make this statement true, and so we've simplified it to say, well, what we're looking for on the unit circle is when sine theta is positive, root 3 on 2, or negative root 3 on 2. So that means we're going to have 4 solutions. Okay, so talking about the positive values of sine, being root 3 on 2, and the negative values. So let's look at our unit circle. Thank you, pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi. Excellent. Okay. Now I might rub this first board out. Any issues? Okay, so this question here, there are 2 procedures we can use to answer it. Okay, so it says find cos theta and tan theta given sine theta is 3 on 5 and pi on 2 is less than theta, which is less than pi. So it's given us a specific reading. Okay, so that means it's going to dictate whether our answer is positive or negative. So let's do an algebraic process first. Remember, cos squared theta plus sine squared theta equals 1. Okay, this is one of our identities, one of the 3 identities, fundamental identities of trig that I've said. And what we're going to do is we're going to put 3 on 5 where the sine is, and then just solve that equation for cos. We're just going to substitute that where the sine is. So we're going to have cos squared theta plus 3 on 5 is 3 on 5. So sine theta squared will be 3 on 5 squared. And let's just go ahead and solve this. That's going to be 9 on 25. Sorry. Plus 9 on 25 equals 1. We're going to subtract that 9 on 25 from both sides. And so we've got cos squared theta is 16 on 25. Square root both sides. Questions? So that's cos theta. I'll show you the other procedure to find cos theta, and then your tan theta is just going to be sine divided by cos. Now, sorry, we're not finished. We need to consider the region. Okay, so here's our unit circle, right? And it says, you know, here's 0, here's pi on 2, here's pi, 3 pi on 2, and then to 2 pi. It says from pi on 2 to pi, so it's talking specifically about this region. So we had two answers. We had positive 4 on 5, okay, so we've got 4 on 5, or negative 4 on 5. That's what that plus or minus means. It means there's two answers. Now, in this region, okay, we've found cos. Is the cos value negative or positive? Okay, so this is our y-axis on the Cartesian plane, isn't it? So that means our x values in this region are negative, which means this is not a solution. Okay, so we reject that solution, and we reference the region. Why is it rejected? Because pi on 2 is less than theta, which is less than pi. And so this is the solution that lies within the region it dictates for us. Okay, so if that process seems a bit fuzzy, that's probably because you used the other one, which I'm going to show you now. Okay, everyone ready? What we do for the other process is we draw a triangle. All right. Now remember SOHCAHTOA. Okay, so sine is O on top of H. Now we've got sine theta is O on top of H, and we're told sine is 3 on top of 5. Okay, so in this right angle triangle here, we just put in theta and a right angle. And so if we're going to label this triangle, this is our opposite side, this is our hypotenuse, okay, it being the longest side, and this is our adjacent side connecting theta and the right angle. They're next to one another there. So we've labelled the triangle, and we can see here O corresponds with 3, and H corresponds with 5, so we put a 5 there. And then we're just doing some Pythag to find A. So we've got A squared plus 3 squared equals 5 squared. And we can rearrange this to get A by itself. We'll have A squared is 25 take 9. A squared is 16, which means A is 4, plus or minus 4. Okay, and then, so all I've done there is done Pythag to solve this triangle for A, and then we remember cos theta is A on top of H. Now, our A value is plus or minus 4, and our H value is 5. And we've generated the same solution as we have over here. Okay, plus or minus 4 and 5. And then we can repeat the process where we reject the solution that's not within the region we're talking about. You can use either process if you prefer. Okay. And then to find tan theta, tan is sine divided by cos. Okay, so we could do that whole thing again. Or we can, from the triangle here, we remember tan is O on top of A. Tan is O on top of A. So O is 3 and A is plus or minus 4. Okay, So we've got a tan value of 3 on plus or minus 4, but we still need to consider the region for tan, okay? So in here, what we have is we have cos is negative. So remember, tan is sine divided by cos. So in this region, we've got sine is positive, the y values are positive, but the x values are negative. So if we have a positive number divided by a negative number, our answer is going to be negative. So again, the same thing. Tan is negative because of the region it appears in. The other thing we do tell you about the unit circle is the all students talk cool.
Can you just say crap?
And so what that means is all trig ratios are positive in this region. Only sine is positive in this region, so both cos and tan are negative. Only tan is positive in this region, T for tan, so that means sine and cos are both negative. And only cos is positive in this region, so sine and tan are both negative. So you can remember that one. And so that can help you just answer the solution as well. But be intuitive about it, know the region you're talking about, know it is sine or cos, negative or positive. Okay, any questions about our algebraic process there? Fantastic. Let's look at some graphs. Okay, so we have the general sine function. You can see the sine and the cos function. So the sine function starts at 0, and in red there, and the cos function starts at 1. And we have all of our information about how A, B, C, and D affect the graph, what the period is, and what the wavelength is. All right. So the first one, we've got this table here, and we've got amplitude and period, and we've got y equals 2 sine x. We've got y equals a third sine 4x, and we've got y equals cos 0.5 cos of pi on 3x. Okay, so we've got 3 functions, and we need to input the amplitude and period into them. So just if we have a wave function, all right, amplitude is the distance from the x-axis to a peak or to a trough. That's our amplitude there. And remember, if we have the a sine b of x takes c plus d, this value is the amplitude, a out the front, okay? Because what it's doing is it's multiplying any sine value by a, so it's pushing it further away from the x-axis, it's stretching it. So here we can just say amplitude's 2, amplitude's a third, and amplitude's half. All right, it's just a number out the front. Now the period involves a little bit more working out. So to calculate the period, what that means is it's the distance for one wavelength. It means how far is it for one whole peak and one whole trough. Okay, so that's one whole wavelength. Now just for a cos function, it starts like this, doesn't it? All right, which means that there is going to be one whole wavelength, because you've got half a peak here and half a peak there. That makes a whole peak and a whole trough. So that's one whole wavelength as well. It just means the distance for one whole wavelength. So the distance for one whole wavelength is 2 pi divided by b, where b is this coefficient here. Okay, so we can just go through and calculate the periods in here. So let's do that. Here the value of b is 1, isn't it? There's no number there, so it's 1. So 2 pi divided by 1 is just 2 pi. Here we're going to have 2 pi divided by 4, which is half pi. And here we're going to have 2 pi divided by pi on 3. Okay, now, again, I like to think about those fractions. 2 pi by itself is 2 pi on 1, which is pi on top of pi on 3. And then we have AD on BC. So 2 pi times 3 is 6 pi on top of pi. 1 times pi is pi. AD on top of B times C. Pi 5's will cancel, so the period here is 6. Okay, so remember, that's what period means. It means how long is it for one wavelength. The other way to think about it is this value of B tells you how many wavelengths appear in 2 pi. Alright, so here the value of B is 1, which means we have 1 wavelength in 2 pi. Here the value of B is 4, which means we have 4 whole wavelengths in 2 pi. So for instance, if this is 2 pi, we're going to have 4 whole wavelengths. So we're going to have 2 there, we're going to have 1 whole wavelength by the time we get here. So it's like this. So we've got 4 whole wavelengths in 2 pi compared with 1 whole wavelength in 2 pi. And here we have pi on 3 wavelengths in 2 pi. Remember, pi is just a number, 3.14. So if we have pi on 3, it's like 3.14 divided by 3. So it's just over 1. So it means we have just over 1 wavelength in 2 pi. Excellent. Okay, so that's our table. And then we've got find the equations. Okay, so these are always a little bit tricky. So this is our base function, a sine b of x makes c plus d. Now the one we've got here is 2 pi, is 4 pi, here is 6, 2, that goes from 6 down to 2, principal axes. So the principal axis, all right, is an invisible line. It also corresponds with our value of d. We call that our principal axis. That's the line about which the wave propagates itself. Okay, it's the same distance above as it is below the principal axis. And any other information? No, I think we're good. Okay, so first we can identify the value of d. All right, the principal axis is halfway between these 2 points, isn't it? So halfway between 2 and 6, well, you have to go up by 2 to get to 4, and then up by another 2 to get to 6. So that means our principal axis is 4. And so if this is 4, it means our amplitude is 2, okay? Because the distance from the principal axis to a peak, or a principal axis to a trough, is 2 units. So we've got D is 4, A is 2. There's no horizontal translation. It's very rare that you would see horizontal translation. And then our value of B. Okay, there are a couple of ways to do this, but I think simply, I'm going to show you both ways. Okay, so the first way is to just go, well, how many wavelengths are there in 2 pi? So if we go from 0 to 2 pi, how many wavelengths, it's not right on, but how many wavelengths is that? Half. It's half a wavelength, okay, which means our value of B is half. So you can just look at it like that and be intuitive. Or you can go, well, there's 1 whole wavelength in 4 pi, okay? So remember, the period is 2 pi divided by B, and so our period is 4 pi. So 2 pi divided by B equals 4 pi, and we can solve this equation for B. We're going to swap the B and the 4 pi. 2 pi on 4 pi is B, and we've got B is half. Okay, so either of those will get the period for you. And so we've got everything we need for, is it a sine function or is it a cos function? It's a cos function because it's starting with a peak. So we're going to have 2 cos half x plus 4. That's going to be the equation that describes this graph. Okay, let's have a go at the next one. I'll draw it a bit bigger. Anyone on here?
Can I just take a photo?
Yep. What I'll do, I'll leave it up. I'll leave it up, guys, and I'll spin it around. I'll just keep moving. Drawing this down. Excellent. So B. So it looks like this. Goes to 2 pi. Pi. Starts at minus 3. Goes up to minus 1. Minus 5. And I think that's all the information we have. Okay. So again, we can see our value of D quite clearly. Our principal axis is minus 3. Our amplitude is always positive, okay, because it's always talking about distance, not direction. So our amplitude in this circumstance again is 2. And our value of B is very easy to see here. How many wavelengths are there in 2 pi? 2 whole wavelengths in 2 pi. So B is 2. So that means, and this one, it's a sine function because it's starting at the principal axis. So 2 sine, 2x, take 3.
In the booklet, it's got 3 jigs. Am I looking at the wrong one?
Should be. What is that?
2B, it's got 3 wavelengths.
Oh, yes. Hang on. 1, 2. Oh, it's 2.5, isn't it? 1.
It ends at the same point it
2.
starts.
Oh, yeah, sorry, you're correct. 3 wavelengths. So count carefully, guys. These 3. Okay. I haven't drawn it properly up here. It's more like this. Thank you, Carly. Good pickup. And so pi's going to go there. There we go. That's a bit better. Everyone okay with that? Fantastic. Okay. So there's not very many questions in the textbook on trig, which is good. 1D, and that's all we're going to focus on today. So let's get into it. I'll come around and catch up with everyone individually, and then I'll go through some common questions about 1C.